In a conventional rear-wheel drive, engine and transmission are mounted longitudinally at the front. Drive is transmitted to a rear axle assembly by a propeller shaft. Beam-type rear axle assemblies enclose the final drive gears, differential gears and axle shafts in one housing. Vehicles with independent suspension have the final drive unit on the chassis frame and transfer the drive to each driving road wheel through external drive shafts. Vehicles with rear or mid-mounted engines normally use a transaxle and transfer the drive to the driving road wheels by independent drive shafts. In beam axle applications, suspension action makes the final drive assembly rise and fall relative to the vehicle frame. This produces continuous change in the distance from the transmission output shaft to the final drive pinion, and in the angle between the propeller shaft and its connections. In addition, the pinion nose is forced up on acceleration and down when the brakes are applied. Despite these movements, the propeller shaft must transfer the drive smoothly. Change in length is accommodated by a sliding spline in the shaft. Angle changes are provided for by a universal joint at each end. For independent suspension, universal joints help align the transmission and final drive, and a sliding spline is still included to allow for slight variations in length. The external drive shafts to each road wheel have universal joints at their connecting points, and often a sliding spline or a plunge-type joint. Some applications use a two-piece propeller shaft. The front section of this shaft is supported at its rear end by a center bearing, bolted through a mounting bracket to the vehicle frame. Provision is normally made for adjusting the alignment of the two shafts.